Okay, so let's start off by doing two warm-up problems before we try the main problem. For this one here, the square root of that expression would be 6a to the power of 18. You square root the coefficient, and then what you do when you square root this is the procedure is you take half of this. That's how you get 18. Okay? What about for something like this? The square root of 50, I'm not sure. It's not as friendly as the square root of 36. Furthermore, taking half of 36 to get 18 is easy. But what do I do if the number is odd? So the recommendation for a problem like this is to break it up into two smaller square roots. What goes in here? Well, first let's break up the 50. How do I break up the 50? Consider a list of perfect squares. Which of these is the biggest number that can be divided into 50? Well, not this one, not this one, not this one. This one, 25. 25 times what? 25 times 2. That's how you get 50. For W43, again, we don't like it because I want to take half of this to get that. But this is odd. So break it up as follows. W42 and W1. You just take the biggest even that's underneath it, in this case 42, and this receives the additional or the leftover W. Now let's simplify this further. This can be square rooted nicely. That'd be 5W21. And this just goes along for the ride. Done. That's it. Let's try this one here. Square root 98. 98's kind of funky because it's not nice like this. So we're going to have to break up this 98. So let's break this up into two smaller square roots. The bottom is essentially done. It just goes along for the ride. How should I break up 98? Go back to your list of perfect squares. Which of these is the largest number that goes evenly into 98? By examination, it would be 49. 49 times what? 49 times 2. That's 98. For x9, break it up as x8 with a spare x. For y16, you don't have to rip it apart because 16 is even. Leave it as is. Now let's simplify this if possible, and it is possible. So we get back what? Well, the bottom stays the same. Just drop that in as is. For this piece here, square root these pieces accordingly. So that becomes 7x4 y8, and that piece stays the same. And now we look for finishing touches. We look for finishing touches. For instance, the 7 and the 14, these can be reduced. So can the y's and the x's. So as a final result, we get back the following. We get back what? This disappears, but it turns that into a 2. These x3s go away, but it turns x4 into just x. Who has more y's? The top or the bottom? The top has more y's than the bottom. How many more? 5 more. And this square root expression stays. So this would be our final result. A quick comment before I let you go. All of this procedure changes the moment you see a radical that has a different index, because all these problems here, although not stressed, there are invisible 2's, square roots. But if the index is different or if the root is different, then our approach would completely change. So all this strategy that was given in this video only pertains to the cases where you have square roots. Okay? If it's something else, our approach would be totally different.